A pharmacist makes a standard morphine sulfate intravenous infusion of 50 milligram morphine in 250 milliliter D5W for a patient. Before the solution could be used, the prescription was discontinued. Rather than discard the solution, the pharmacist decided to use it to make some solution for patient-controlled anesthesia syringes, the usual concentration of which is 1 milligram per milliliter. How many milliliters of a 15 milligram per milliliter stock solution of morphine sulfate will the pharmacist have to add to the 50 milligram by 250 milliliter solution to produce a final solution with a concentration of 1 milligram per milliliter? Round answer to the nearest tenth and do not include units. So I'm going to write what it means, what this question is asking for. So you have 250 milliliters of this concentration, because we're going to be using the entire bag. This here, 50 milligrams per 250 milliliters in that whole bag. And then we're adding some unknown amount that we need to calculate of a 15 milligram per milliliter stock. And then we're going to try to make our solution final concentration to be 1 milligram per milliliter. And this is actually the 250 milliliters plus the n milliliters of what we're calculating. This is what it means if I were to write out what we're trying to do. We're trying to find out this n. So now I'm going to draw pictorially what I'm trying to calculate. So I have this beaker here. So initially, this pharmacist has a 50 milligram per 250 milliliter intravenous infusion. So I'm going to call this the 50 milligram per 250 milliliters. And then I'm going to be adding some unknown amount that I need to calculate of this 15 milligram per milliliter stock. So I'm going to draw this other beaker here that has 15 milligram per milliliter. This stock solution bottle is technically infinity, right? Because stock tries to mean you have an infinite amount kind of thing. Because we need to know how much of this liquid here, from this liquid, I'm going to add to this 50 milligram per 250 milliliter concentration. So these drops as amount would be the n that I'm trying to calculate. Okay, so the first thing I'm going to do is convert these to the same units here. This and this, I'm trying to convert them to the same units. So I'm going to start here. This 50 milligram per 250 milliliters. And then I'm going to force set this to some amount over in milliliters, because I'm trying to put the units per milliliter. Because I'm trying to convert to 1 milliliter in the denominator, because the other concentration here is in milligrams per milliliter. So I have to make them the same, because I'm going to be using allegation for my calculations. So when I calculate this, I get x equals 0.2 milligrams. So this 50 milligram per 250 milliliters, this is the same thing as 0.2 milligrams per milliliter. I know some of you are just saying oh, just divide them both by 250, the numerator and denominator. Yeah, you can do that. I'm just trying to make it easier for those that are not really good at math. So this solution that has 50 milligram per 250 milliliters, this is the same thing as 0.2 milligrams per milliliter. So now I'm going to do allegation, because I'm trying to use this solution that they were made plus a stock solution, and I'm trying to make this 1 milligram per milliliter. So when you do allegation, you just get one concentration. Well, this time I'm using concentration, 15 milligrams per milliliter, and then I got a 0.2 milligram per milliliter. Right, so I got one strength here. This is I just converted this 50 per 250 to 0.2 milligrams per milliliter, and then I got my 15 milligram per milliliter stock solution. And then when you do allegation, you put these two lines here, trying to make a 1 milligram per milliliter solution. And then you just follow the line through. So 15 minus 1, that equals 14 parts. And then 0.2 minus 1, you just take the absolute value. You don't have a negative number. You get 0.8 parts. 0.2 minus 1 equals 0.8. So when you do allegation, you just look at the bottom half after you calculate this. So this 14 parts, it represents how much of this 0.2 milligram per milliliter to use. And if you notice in the question, so because the pharmacist, they made this already, and they want you to use exactly 250, all of it, 250 milliliters. So must use 250 milliliters because it's already made, and we're adding this unknown amount of stock into this 0.2 milligram per milliliter solution, and that represents 14 parts. So that's why when you can just do a proportion. So 14 parts over what we need to use, well, we're forced to use all of it, 250 milliliters. And then I set that to the other strength, which is 0.8 parts. How much of this to use? I don't know. That's why I'm calculating it over N. I'm just gonna, N is the amount that of this 15 milligram per milliliter that I'm gonna use. I mean, technically you could have inversed this, like you could put 250 up here, but your units have to be the same across. So if you put 250 milliliters in numerator, then your N would have to be in the numerator here. And then the parts, both of the parts have to be in the denominator. It doesn't really matter. You just have to be consistent in having the numerator having the same units as the numerator, and the denominator having the same units as the denominator. So when I solve for this, my N will be 14.285771429 milliliters. So that's how much of this 15 milligram per milliliter stock solution I'm going to use. And that's what the question is asking. How much of this stock solution to use to make a final solution of 1 milligram per milliliter. And then follow the instructions by rounding the answer to nearest tenth and do not include units. So this number rounded to the nearest tenth is 14.3. And that's what you would enter in the computer. You don't put it in units because they tell you to use, well, they will tell you to use milliliters and not include any units. And that's it for this question. So if you understand that, you should stop now, because I'm going to explain a more difficult way that would help if you're really good at math and you need to double check your work. Another way to calculate this amount of the 0.2 milligram per milliliter to use, I like to use algebra to do it. So if you were to use algebra, you would take the 14 parts and then also add it to this 0.8 parts. So I'd add them together. So I like to put it over the total, because whenever you take this over the total and then you multiply it by the total amount in the whole bottle, so both of these two included, right? Because even though I don't know the amount right now, I'm going to try to calculate that. So the total amount of here, this amount, this amount of fluid from this solution, plus what already had the stock solution, which is 250 milliliters plus N, because I have to use the 250 milliliters total in the first solution, and then I'm adding an unknown amount of this 15 milligram per milliliter, and that equals how much of this 15 milligram per milliliter stock solution I'm going to use. So that's why I set this equal to 250 milliliters, because I'm only doing this bottom half here, and I know I have to use 250 milliliters. That's why I set that equal to 250 milliliters, because that's how much to use. So when I calculate that, 14 divided by 14.8 is 0.945949595. And then you have a really bad calculator. That's why you have to do that. I do it one by one. So when I take this decimal, 0.94594,595 times it by 250. I get 236.486486 plus this number again, 0.945945595 times it by n. That equals 250. And so now I'm just going to subtract both sides by 236 point this. Shit. So that equals 0.94594,595 equal to 13.51351,351. So now I'm going to divide both sides by this number, and you should get n equals 14.285,71422. Right? It's the exact same number. Well, I know there's a slight rounding error, but then it's the exact same number as this right here. So that's how you know you did the right answer. So now to really double check your work, I'm basically working backwards. So I know I have this 14.3 milliliters, right? This is of the 15 milligram per milliliter stock solution. Right? It's being added to the original 50 milligram per 250 milliliter solution. All right, so now I'm going to calculate how much drug is in this 14.3 milliliters of the 15 milligram per milliliter. So I'm just going to take the 14.3 milliliters, multiply that by the 15 milligrams per milliliter. Right, milliliters and milliliters cancel out. That equals 214.5 milligrams. And now I'm going to combine the amount of drug over the total solution to get the concentration. Right, so the total amount of drug is 214.5 milligrams, which I just calculated. Plus, you don't need to calculate this because they tell you the amount of drug because you're using this whole solution. So it's 50 milligrams over the total amount of the solution in milliliters. So I'm using this 14.3 milliliters plus the 250 milliliters. And then when you calculate that, that should be about 1 milligram per milliliter. Right? So I basically worked all the way backwards to this. That's how I know for sure that I'm 100% correct and can just move on to the next question. Oh, if you have any questions, please leave it in the comments. Oh, and here's a joke before you leave. You know, patient-controlled anesthesia. What do you tell a patient who wants to administer their own patient-controlled anesthesia? Knock yourself out. Okay. Well, that was my joke. Have a nice day. Bye.